All right, so here we're using the data in this table down here to find the probability that a U.S. woman aged 40 to 49 has a positive mammogram given that she has breast cancer, and then has breast cancer given she has a positive mammogram. All right, so A, probability it's a positive mammogram given they have breast cancer. All right. So if they have breast cancer, how many is possible for that? Well, there's 800 possible with breast cancer. So we know our denominator is 800. Now, how many of those have a positive mammogram? Well, 720 have a positive mammogram. And so if we reduce that, that's going to be 72 over 80. So that's going to be what, 9 over 10, I think. So that's going to be 9 over 10. Now they want this as decimals, I guess. So we actually just want 0.9. Okay, so that one we just needed to have as a decimal. All right, so that's A. What about B? In this case, we want it the other way around. We want the probability you have breast cancer given you have a positive mammogram. Okay. Well, positive mammogram, that one here, let's put these as squares. That's going to be 7664. So that's our denominator in this case. Now, how many of those are breast cancer? Well, now we have 720 again. So that's going to be 720. Now this time I can't do that in my head. And since they want it as a decimal, we're just going to go to our calculator. And we're going to take our 720 divided by 7664. And we get 0.094 if we're going to 3 decimal places. So we get 0.094 for that one. Okay. So that's the last problem, but we still have a little bit here. And so this one says, this is kind of giving you a little more ways to say things. So we have seen that the probability of B given A is the probability that event B occurs if the sample space is restricted to that event A. So whether it's the mammograms or the spades or whatever. And so the probability of B given A occurred is going to basically be the number of outcomes of B that are a restricted sample space A divided by the number of outcomes in a restricted sample space A. Now we've seen that several times. Here, that's our sample space. Here, that was our sample space. And this was, in both cases, our numerator, which is the number of outcomes that are in that restricted sample space. Okay. Now, this can also be stated in terms of using set notation and set theory, where we use B intersect A means the intersection of B and A. So the probability of B given that A occurs is equal to the number of B intersect A, where they have the same outcomes, divided by the number in the outcomes of A. Okay, so these are a couple other ways to represent what we've been doing in some of our problems. And so if this works better for you to think of it this way, that's fine. If it works better this way, that's fine as well. Or how we kind of did it in the actual examples. All right, so that's all I have for this section. So hopefully that helps.